The router uses its own interface to impersonate the address of PC3. Reply a MAC address to PC2. The proxy function of ARP we talked about today. It is enabled by default on Cisco devices. So when the PC sends, it is able to help forward by default. Okay. We just looked at the message on the left. Let's now look at the message on the right. That is the interface on the right. I pause. Start here. A message is now sent. PC3 is 192.128.0.100. Tel 192.168.0.254. So it is. Who has PC3? Right interface of Tel router. Because this is the packet captured under this interface. It is equivalent to another ARP request now. Is sent through this interface. Then the corresponding PC3 replied to it. 192.168.0.100 is at 005079666803. Here is the real MAC address of PC3. The device on the left asks the router. The router replies with an interface of its own. Then the router asks the device on the right. The device on the right puts the real MAC. Told the router. When the final forwarding. The device on the left sends data to the router. The router helps forward the device on the left encapsulates the MAC of the router. The router encapsulates the MAC of the device on the right. The PC now interacts with the left and right interfaces of the router. This is an interactive process between them. Then we make a simple summary. Let's continue to look at this picture. For routers. Proxy for ARP on Cisco devices. The interface is to enable the proxy function of ARP by default. Then when PC2 sends a request to the left interface of the router, it requests a MAC address of 0.100. When the device receives an ARP request, if the target IP it requests is not it simply drops the packet. But now the router will not drop the packet directly. As long as the ARP proxy is enabled on this interface, it will not directly drop the packet. It will look at who the message is looking for to ask for the MAC address. It is now looking for 0.100 to ask for the MAC address. Then it checks to see if there is any. If so, it will reply to it. But if not, it will activate its own ARP proxy function to help the equipment. Certainly. It's also not the actual PC that replied. It also responds to this interface. Otherwise retweet. There is no way for you to package the MAC. In the next paragraph, the reply is also this interface. It's just that it involves the question of asking again. Not everything. The router itself has to be able to. I give an example. Suppose you have a question you can't do now. You think I will do. So you need to find a good person to ask. But you don't actually know where this guy is. You send this data packet. Can't even get to this place. The data packet arrives at the router in the middle here. It doesn't know if it will do it. But this data packet arrives here. Logically speaking, the router is not the guy you're looking for. It won't know your question. It drops the packet. Then for the device. Since the device has proxy function enabled, it's like it's now helpful. If you now send a packet to it you have to ask it a question. This question it won't. But it can help you ask. Ask the person you want to ask. But the premise it asks is, it knows this person. It's the same in this picture. The data is now going from 1.100 to 0.100. Since PC2 is now requesting 0.100. Router is not 0.100. It will help PC2. Not directly discarded. It goes to help PC2 ask PC3's MAC. But only if it knows where the device is. That is, it has to be connected to PC3. It needs to have a route to PC3. If now a line connects the devices at both ends, an address is configured on the left. An address is configured on the right. The right side is called the direct route on the left side. A direct route will be generated on the router. Since we are now going to visit the network segment of 192.168.0.0, it is a direct route of PC2. So it can reach. It's okay if you don't understand here, because many knowledge points in the course are coherent. So it is easy to encounter knowledge blind spots. When we talk next class, let's have a deeper understanding. Here is a direct route. There is also a routing table. There is this representation in the routing table. Prove that the router can reach. PC2 now sends a message to the router. It doesn't matter. Although this broadcast packet can't get through, the router can help PC2 send another broadcast packet to request. Because this broadcast packet can pass, is due to the isolation of broadcast traffic by the hardware. This router can't help PC2. All it can do is help send another packet. Help to ask. This is what we call ARP proxy. It will help to send another ARP. Then when this ARP is sent, just use your own MAC address as the source. I went to PC3 for the address. Later, form an ARP cache locally. But although there is a local cache, but it won't cache this to PC2's. That is, PC2 is requesting a MAC of 0.100. While the R1 has gotten its MAC, it also doesn't tell PC2's. If the left device, it is really packaged by the MAC of the device on the right. PC2 is under this broadcast domain. Can't reach PC3. What we call encapsulation based on MAC address. It is performed under a broadcast domain. It is a concept on the link. PC2 cannot find the peer device. So it can only find the router in the middle first. Let it do a retweet. All data encapsulation required. The router will have an ARP cache. ARP cache it corresponds to. It is a correspondence between an IP address and a MAC address. Then everyone has to think about the corresponding relationship. As long as a device wants to send data. Data encapsulation. Just perform data encapsulation. IP address and MAC address must be encapsulated. Then as long as you need to encapsulate, then there is ARP cache. So the ARP cache is present on all devices that will communicate over the network. Whether PC, router, firewall, switch, all have ARP cache. Certainly, the switch has to be a layer 3 switch. Otherwise, you don't even know what an IP address is. There will be no correspondence between IP and MAC. Let's take a look. First, the two PCs can be pinged. This is what we have verified. We can do a verification on R1. Let me check. ARP on my device now. Okay. Everyone can see. For me now, I have a corresponding ARP on my device. And the information I got is correct. In addition to the interface on its own body. It does not count. This is 0.100 for MAC. This is 1.100 for MAC. The one on the left is 050079666803. The one on the right is 005079666802. We can also take a look here. 005079666802. This is the left PC. Let's check ARP on PC1. Everyone will find Here there is 192.168.1.0. That is the ARP of the right PC. This is what we just demonstrated by capturing packets. The left PC thinks. Now the address of 0.100 is AABBCC. Data encapsulation. It is encapsulated like this. For PC2. It does not know that. The router has opened a proxy function to help itself. It thinks they are on the same network segment. PC3 reply is the same. It thinks they are on the same network segment. PC is unaware. Middleware help is a function that it enables. The PCs at both ends regard it as a mutual access. On the same network segment. To us. It also doesn't have to be a physical direct connection. It's not necessarily connected by a single thread. It may also be connected through a switch. Anyway, a network segment is directly connected. As for passing through the router in the middle, they don't know. Okay.